You see that chapter, poles on the real axis. That is the improper integral when the poles on the real axis. So previously there is no poles on the real axis. The question is like that, sin x by x, because x is equal to 0 on the real axis origin. Cos x by x, x is equal to 0 on the real axis. So x square minus ix denominator. So x is equal to 0 on the real axis, another is x is equal to I on the upper half of the z plane. So 8 minus s cube denominator. That is, it will be x is equal to 2 on the real axis, and another you will get 2 real upper half of the real axis, and another is lower half of the real axis. Similarly, fifth question like that. So those poles are therefore, since real and that is in these questions, you will find include two parts. We will find the poles, those poles lies on the upper half of the z plane. That is, the answer is 2 pi I into some of the residues, those are in the upper half of the z plane. Plus, so those poles on the real axis, that is indented integral, it's called as. So that is, the answer is, that is another we have to add, it is pi I. Pi I, residues of the poles, those are on the real axis. Pi I, that is residue of the poles, those are lies on the real axis. So this is a formula figure, that is, if z is equal to a pole lies on the real axis. A means 1, 2, 3, 4, 5, 6, or minus 1, 2, 3, like that on the real axis. Then as previous, we can draw a circles with the center at 0 and radius is equal to capital R. When R tends to infinity, that is it is cover whole half of the z plane, and the since integral is minus into infinity, therefore we take minus R to R. So the contour is like that over circumference of semicircle, then come to minus R, then over moves along the real axis from R to R through that singular point z is equal to A. So since it is a singular point z is equal to A, that is called gap. Therefore you draw a small circles around A with small radius R, and that circle is denoted by CR, small CR. When R tends to 0, so it will become point circle. When R tends to small r tends to 0, that will become point circle, that is only A point. So that is, one is capital R, another is small r. So capital R is when R tends to capital R tends to 0, then it is extended to whole complex plane. When here R tends to 0, you remember capital R tends to infinity and small r tends to 0. If it tends to 0, it will come to point z is equal to A. So you imagine that circles that is with radius, small radius about A, taking center as A, radius R, that is circle is CR. So we have to find what is the integration over that CR, that is called indented. That is called, because this is because of this part, it is called indented. So what will be circumference? What is the boundary of your contour, close contour? That is C. Always you are taking your close contour. It will become circumference of the big circle CR plus minus R2. You see A minus R. Why it is A minus R? Origin at origin it is z is equal to 0. Here z is equal to A. So you see this point, that is minus R to which point? That is the left side of A. Left side only, if this gap is a small r radius, that will become A minus R. Then plus CR,
Here you see then plus here. Then come to this point. What is that point? That is, it is greater than A. That point is greater than A. That means we have to take A, 0 to A plus radius, that is A plus R to R. That is your counter. That is your is bounded domain is bounded by this counter. C is equal to CR minus R to this. So what will do here? So if you split the integration of the closed curve is equal to integration of CR plus minus R to A minus R plus CR, small CR, over the small circle. So A plus R to R, that is f of x, because since it is along the real axis, z is equal to x. So that is 2 integral on the real axis and 2 are over the capital R, another is small r, fz. So here if you take small r tends to 0 and capital R tends to infinity, what will happen? So left side is unchanged because it is a counter, closed counter. And the result of left side is 2 pi I into sum of the residues, right? So residues within the contours. So now here is equal to CR 2 pi I. When limit R tends to capital R tends to 0, first integral tends to 0 as previous. When capital R tends to 0 and small a tends to capital R tends to infinity and a small r tends to 0. So what will that? Minus into a f of x dx. Here small r tends to 0, limit r tends to 0, integral over CR fz dz plus here this will be a to r. You see it is a continuous. You see that it is a continuous function, minus r to a plus a to r over the same functions. If you combine, it will become, that is, if r tends to infinity, that is minus into infinity. The integral become minus into infinity. You have I have written here. You see. So limit capital R tends to 0 infinity and capital small r tends to 0. So what to do here? So in actual integral, you take, that is the last term, that is you take left side, actual integral minus into plus into fx dx is equal to, so that is integration of the closed curve anti-clock sense minus limit r tends to infinity CR clockwise. So it has only two integrals. This because this will like the. So provided capital limit r tends to infinity, CR tends to 0. How it is provided? Because here degree of denominator must be exceed by 2 or more than 2 from degree of numerator. It is always, if it happens, it tends to 0. Otherwise, it cannot be true. So it is one is anti-clock, another is clockwise. So it take the same sense. Both are anti-clock. So it will be minus become plus. So it is minus become plus. So you see, I have written minus into f of dx, integration of c f z dz equal 2 pi I into sum of the residues of the poles, those are in the upper half as previous, plus limit r tends to infinity for this. So for this integral, what to do? So you remember that formula is limit r tends to infinity, the integration of CR f z dz is nothing but it is pi I into sum of the residues, those poles on the real axis. This part, limit r tends to infinity, if you take, so here you take CR tends to 0 as a capital R tends to infinity. In that case, you take z is equal to r e to the right theta and do it. But here you should not take, that is z is equal to small r e to the right theta. Of course it is. If you take that part and do it, then we will get this answer. So I am not giving that proof, just to remember limit r tends to small r tends to 0, integration of CR fz is equal to plus, there is pi I into sum of the residues, those are on the real axis. So this is actually formula. Page 2, the first line is the formula for your questions. So here the poles on the real axis means it may be improper only poles on the real axis, and also poles on the upper half of the z plane or lower half of the z plane. Another is that is, it may be Fourier in that is a improper Fourier integral if the poles on the real axis, right? So that is sin x by x, integral from minus infinity to infinity. What is that? That is a Fourier integral. Fourier improper Fourier indented integral, because x is equal to 0, x is equal to origin is the singular point. So you have to find what is the residue at the origin for that case. So actually this is a formula. So it is, this integral is called, since it is indented integral, so that is actually that is a singular point z is equal to a, and there is no circle like that. We are imagining a small circle with radius small r. So therefore it is called principal value, PR. PR means principal value. Principal value of the integral minus to infinity, it is called principal value, PRV or PV. Some book it is given only PV. Principal value of the integral minus to infinity f of x dx is equal to 2 pi I into sum of the residues, those poles on the upper half, plus pi I into sum of some poles, those poles lies on the real axis. So this is the about the theory. I have used the theory for this question. So you see, here z is equal to I and z is equal to 0 are two poles. So I have given theory just like repeat like that as previous. So only you have to calculate the poles. Those are in the upper half. I is equal to upper half. The residue is equal to 1 by I. Poles on the real axis, z is equal to 0 is a pole real axis. So I will calculate the poles. So and the limit r tends to infinity, CR is equal to tends to 0. I have made the proof. So the answer is 2 pi I into sum of the residues. Those are in the upper half. That is only I. 2 pi I into f of I plus pi I. It is not 2 pi I, only pi I. If the poles on the real axis, pi I into residue at z is equal to 0. That is on the real axis, or sum of the residues, those pole on the real axis. Here only one poles. If there are two poles on the real axis, you have to do pi I plus sum of the residues. That is your answer. So second part I have solved here. Already you remember that is a triangle inequality, a plus b mod greater than equal to a minus b mod greater than equal to a mod minus b mod. So here a minus b mod, a minus b mod. So if you take that is a mod minus b mod, it will r square minus r. So if you that is degree of numerator and denominator is exceeded by 2 or more, then automatically if it tends to 0 as r tends to infinity, that is the over. The second question also same. So those are, I have explained, those are not attended in the second class, that is the last class. Ansuman? Hello?
Yes, sir.
Are you understand?
Yes, sir.
That is, you can understand this question if you know the solution of Fourier integral, Fourier that is improper integral, and Fourier improper integral, then that is no, this is, you can understand these questions. You have to just add, previously you take control integration, the value minus into infinity f of s dx dx is equal to 2 pi into sum of the residues. Those poles on the real axis. If the poles on the real axis, then just add plus pi I, sum of the residues, those poles on the real axis. Right? And second part, you have to prove limit r tends to infinity, capital integration over CR, dj, fj dj it tends to 0. So any doubt? Any doubt? Aman? Aman Pani? Aman?
Yes, sir. Yes, sir. No doubt.
No doubt. That means if not only Aman, for all the students, those have no doubt, so they will get full mark, 80 out of 80. Right? And it is not no doubt on the counter. If a students tell, sir, I have no doubt, I clear that he has many doubt. Right? I always quote things. If you walk, then you will fall down. if you not work and sit in one place, then if you ask whether fell down or not, so no sir, no sir, right? So if you solve the questions, then you must have a doubt. If you have no doubt, I think that you are not solved the questions. So again, another class I will give you a chance. You solve once again. So Tuesday you have a one class with you in your hand. Wednesday, one day is for you. There is no mathematics. Wednesday, so you tell me what is your doubt, right? So if somebody will ask the doubt, if some other students solve that questions through this discussion, then I will be very happy, right? All right. So those who have doubt, you stay on the line. Those who have no doubt, you leave the system, right? Okay, so I leave. Lokesh join. You are present or leave?
Yes, sir.
Lokesh, come on, what happens? You are fine.
Yes, sir. I'm fine.
You are from where?
Sir, Raukela.
Raugla.
Yes, sir.
Raugla, which sector?
Sir, Civil Township.
Civil township.
Yeah.
Now, have you understand about the complex analysis or not?
Yes, sir.
ठीक. Rakesh Kumar. Rakesh. Rakesh. Perhaps he will leave.
Yes, sir.
Yes, sir.
Yes, sir.
Rakesh,
Yes, sir.
you are from
Yes, sir.
where? You are from
I'm from Bihar, sir. Bihar,
Bihar.
Bihar.
So
Yes.
now you are fine.
Gaya.
Are Goya. Goya.
Yes, sir. I'm fine, sir.
So I will
Yes, sir.
visit to
Gaya.
Goya. Your home is Goya.
Yes, sir.
Rakesh, I will go to